So good morning to all the participants, and I'm Vinod. So I have close to 10 years of industry experience, and today I'm going to talk about hardware industry in India and then the basics of hardware circuit design. So the content which I would be covering today is the hardware industry overview. So we are going to talk about the hardware industry landscape in India, and then what are the key growth drivers for hardware industry in India, then how much is the employment generation capability of the hardware industry in India. Then we are going to talk about the key basic component which are really important when we talk about the hardware circuit design. Then we are also going to touch upon what are the key challenges in the hardware circuit design. Then we are also going to talk in brief about the key simulation tool which are used in the hardware industry, and we are going to look at a very simple demo of one of the voltage divider circuit simulation to give you a feel how the tool looks like and how the circuits can be simulated. Then we are also going to talk in brief about the hardware products and its application, and what are the different job roles one can expect in the hardware industry once he or she joins the industry. And then we are going to look at very few and key companies which gives the good growth and the job opportunities in the hardware domain. So moving on, so as you can see, when we talk about India, so in the year 2020, the revenue in the hardware market is projected to reach 36,867 million US dollar. So you can see it's a quite big industry, and the largest share which is coming in the hardware industry is from the mobile phone. So it's a needless to say, you would have seen a few months back our honorable IT minister Mr. Ravi Shankar Prasad also spoke about this in various forums, where in year 2014, India had only two mobile manufacturing units in India, and today India is the second largest in the world, where we have close to 200 mobile manufacturing units in India. So you can see the growth which has taken place in a 4 to 5 years time. We have gone from two hardware manufacturing industry to 200. So that's really a tremendous growth in a span of 5 to 6 years. And how do we expect the growth in coming years? So this industry is expected to grow at the rate of 4.5%. So CAGR stands for compounded annual growth rate. And below you see a chart which shows the production of the hardware industry. So mainly you see a growth in the mobile phone market. So in the coming months and years, you see a lot of players. So Apple also has set up now the mobile manufacturing unit in India, and they have also started the R&D, so the design activities also in India. And then the next field which is also growing is the network infrastructure. So we are going to make many network equipments like Wi-Fi and telecom equipments. Then we also have another segment which is growing as the storage devices, servers, then of course the personal computers. Moving on next. So this slide talks about how we started and where do we stand today. So as some of us might already know that the growth or the industrialization started what we call mainly as a globalization in the year 1991, and that is where the economic reforms started to take place in India, and we had a lot of technology exchange with other countries where we could get technology support from other countries to our country, and then we could start building up the products. And then in the year 2000, we had the rise of this business process management industry, and that led to the increase in demand for the IT hardware. Then in the year 2002, we had the boom in the telecom sector. So you could remember that we had many players in the telecom sector who were providing the telecom service like Telenor, Tata Docomo, app. You had Airtel, Vodafone, Idea, and then also the growth or the technology change which we are seeing in telecom sector. We are going from 2G to 3G, 3G to 4G, and now we are already talking about 5G. So definitely this is also giving a lot of growth opportunities for the telecom operator to develop, design, and manufacture the new hardware. And then we also had good growth in 2006 to 2012 in the healthcare sector and the defense sector, where the government itself had a keen interest in developing the defense equipment within the country, because today we have huge import from France, from China, from US, where we are importing a lot of defense equipment. So that is where the government brought in the key policies, where they were looking for the industry players who could design and develop the products in India. And of course, it's a long term activity and it is still continuing. Then from 2013 onwards, we also had some key policies from the central government which boosted the domestic production for the electronic products. And we also had the demand in the solar energy. We also had the semiconductor manufacturing plants in the country. And you could remember our honorable prime minister, when he became the prime minister, he gave the slogan that we need to do design in India, make in India, and then sell it to the world. So this is really important because we are a country of 1.3 billion population. And if we have to fill the aspirations of everybody, then we need to have good manufacturing and the design setup within our country, where we are able to fulfill our local demand rather than depending on the import from the other countries. And then here we see what are the sectors or what are the factors which are responsible for boom in the electronic industry in India. So the one of the main reason is the growing demand, because our population base is so long or so huge that we need to first fulfill our need itself, so which we are currently doing it via import. So there is a huge opportunity that where companies can come in and set up their design center, their manufacturing center, and then they develop the product which could meet the demands for local. So you see increasing consumer and the business demand for electronic and IT hardware product, which is going to touch 24 lakh crore mark by 2020. And then, as I spoke about this lack of domestic manufacturing, so currently we are depending on the other nations for our needs. So there is a huge scope wherein which companies can come and set up their design center, their production center in India, and then we could fulfill our demand by having the local production. Then we also had some government initiatives which were driving the demand from central government and state governments. They had their own projects. We had one project called Akash Tablet, where government had the vision to give the tablet to all the engineering students, where you could go from offline to the online way of education. And then nowadays we see a lot of policy support from even the state governments, where states are fighting to set up the, especially in the automotive domain, you see a lot of focus on the EVs nowadays. You have the battery cell manufacturings, inverters. Then we see a lot of focus on the solar because of the reducing the carbon footprint, and then many more. So these are the key initiatives or the key parameters which would drive the growth of the hardware industry in India in coming years. And moving on to the next, so here you see the market size. So I mean, you can see year on year the industry is growing, and as we have seen previously, it is expected to grow further at an compounded annual growth rate of 4.5%. And on the right hand side in a chart, you see the breakup of the Indian electronics and the IT hardware sector. So you can see 34% share is coming from communication and the broadcasting equipment. Then you have this computer and the peripherals 15%, consumer electronics 26%, others is 90%, and the semiconductor, which is only 6%. So this is the area where where the government has to really focus, because currently India does not have the chip manufacturing company. So we do not have an foundry in India which could manufacture the wafer and then integrate it and then can manufacture the integrated chip. So currently we are hugely dependent on China for this semiconductors. We also have PCBs getting imported from China. So there is a huge opportunities for the companies to come and set up their base in India and serve the need of a nation which is having a population of 1.3 billion. So our own demand is also so huge that if companies are coming to India and then start designing and developing, then I think there is a huge market wherein which they could sell their product before going to outside. Then here you see the employment growth, how much employment this industry is able to provide over a year. So you can see in 2013 in different areas there was an employment generation of 4.33 million. So 1 million stands for 10 lakh. In 2017 we had 6.24 million people getting added into the industry, and in 2022 we expect a 9 million people getting added into the industry. And the employment growth which is expected from 2013 to 22 is 4.61 million. And now, so what we have looked so far is how the hardware industry landscape in India, how the industry looks like, and how much growth we can see, and what are the key driver which would drive the hardware industry in India. Now let's touch upon what are the key component in the hardware circuit design. So any product you look when you look into it, you find the combinations of these of the basic component which are responsible for the integrated circuit development of the product. So you see the combinations of resistors, capacitors, inductors, MOSFET, transistors. So they are used in combinations to design the circuit and meet the needs of the end application. And one of the key component is the resistor. So its basic function is it opposes the flow of electron, that, and it is measured in unit of ohms. And so this is a very basic explanation about the resistor, but the field itself is very vast because you have different type of resistor like chip resistors, you have got light dependent resistor LDRs, you have got thermistors which are nothing but the temperature dependent resistors. So this is just to give you a brief idea. Then second key component in the hardware circuit design is the capacitor. So this is nothing but a storage element which stores the charge and give back the charge when it is needed. And this is usually measured in farad. And we also have different type of capacitors like tantalum capacitor, ceramic capacitor, electrolytic capacitors. So each type of capacitors are used in an application based on their requirement. Then third key component what we have is inductor. So basically it stores the energy in a magnetic field where an electric current flows through it, and this is normally measured in units of Henry. And then other key components which are used in the circuit design is the diode. So this is very important component. So this is normally used for passing the current in one direction. So normally you have different types of diodes like freewheeling diode, you have Zener diode, you have Schottky diode. So each of this diode have got their own applications, and based on their design need they are integrated into the design to fulfill the need. Then we have the transistor. So yeah, it's an active device, or you can say it's a switching device, which is having the three terminals like emitter, base, and collector. So basically transistors are a current control device, and you have basically two different type of transistors like NPN transistor and PNP transistors. And then other component we have is the MOSFET. So this is also an active device, but it's the difference between the transistor and the MOSFET is that the MOSFET is a voltage control device, and it has also got three terminals like drain, gate, and source. And we have got two types of MOSFET: N-channel MOSFET and the P-channel MOSFET. So these are the key basic component which are used in every circuit based on their design need. Now this may look so simple that this is the end of the hardware design, but it is not. The hardware circuit design is really complicated. So recently, the CEO of Google, Mr. Sundar Pichai, he made a statement around few months back, and he said hardware is hard. So being a CEO of Google, which is a software company, he made a remark in one of the forum that hardware is hard, and this is really true, because one has to have a real good understanding of the basic principle of this component. Because in an industry, when you develop an hardware product, it has to go through the very intensive design phase, very intensive verification, very intensive validation phase, and then only you could take it to the series production, and then you could sell it to the end consumer. Now you just imagine the risk, even if there is a very small bug in the product due to a design error, the product has to be scrapped because of the industry norms, because of the safety norms. And normally, when we are talking about the automotive industry, you could imagine the volume which is running into millions of pieces. And that is the reason that this in hardware industry is a very capital intensive industry, because the companies have to invest a lot of money in setting up the lab, in setting up the good testing infrastructure, in getting good equipments, and then putting a lot of money on the EMI testings and so on. So there is a tremendous need for real good hardware engineers, and you also can get a good pay if you have real good understanding of the basic principle of this components, and if you are in a position to suggest a suitable component for the design need or the application need. So this is really complex. It's not that easy, but relatively, if you look into the software part, even if you have a bug in the software, it could easily be rectified by changing the lines of the code, and then you can compile the code, and then you can flash it. So the loss which could occur due to a software bug is not that high than it could from the hardware design itself. And this is one of the real reason that you see a lot of software startups coming up, but you see very few hardware startups in India. And this is basically due to the huge capital requirement, and also you need to have very good infrastructure, very good lab facilities, and you need to have very good sharp minded people who have the ability to design the circuits which are meeting the needs of the applications and which are defect free when they get into the production. So in industry we use the term called zero defect. So this is really important in the hardware industry. Otherwise, you could have the losses running into the millions and billions if you have even a simple design error in a circuit. Now, moving on to the next. So here we look what are the key challenges, yeah, when you are designing a circuit. So it's not just that you just select the component, you take one resistor, one capacitor, one MOSFET, and you just integrate it, and you say my circuit is ready. But when we talk about the industrialization, on when we are talking about the manufacturing, when we are talking about the end user application, so we need to think in multiple directions. And one of the key parameter which is posing a big challenge in today's hardware industry is the power dissipation. Because as you know, all the switching components are generating heat inside the product, and then every component has got its own temperature limitations, so beyond which if you try to operate, you will damage the component, and at the end it will damage the product. That means the product will not work as expected. So this is really important. When you're integrating the component, you need to have a good focus on the thermal behavior of the product. And this is really key, because in the today's world everybody is looking at small. So everybody wants to reduce the size, but at the end they want to have more component. And when you have more component in a product, it is generating more heat. And when you're having more heat, there needs to be a way that how this heat can be dissipated to an external world. And it depends on the type of area wherein which you are working. Since I come from automotive, in automotive we need to have a product which is able to meet the temperature range from -40 to 105 degree. So you can imagine the range at which the product has to operate. That means it has to work perfectly at -40 degree, also at 105 degree. So that means the component selection has to be so strong that you are selecting the right component for the right design. The next important parameter is the size of the component. So as I said, you need to select the right component. So if you're just selecting a MOSFET which is bigger in size, so this will of course increase your product size, and then at the end it will increase the cost, which would nobody pay for it. So we need to have a right balance, that do I need high current MOSFET, or can I still manage with a low current MOSFET, and things like that. So this a designer has to really think before designing the circuit, and to ensure that at the end the product is not very big and it is not so cost expensive that we don't find the buyers in the market. The next, as I said, needless to say, the cost of the component, because everybody is looking for the low cost product, because today the competition is so huge in the market that if your cost is not in the bracket as expected by the consumer, then I think somebody else will capture the market. So you need to be really really innovative in designing the circuits, integrating it, and at the end, when you productionize it, the cost has to be kept in mind, that at the end we are able to sell the product. So there's no point in making a fancy product where you give a lot of features but then nobody needs it at the end of the day in the market, and then the cost is too high that you don't find a buyer. And then the another big challenge is the reliability. So this is again a very key topic in an automotive, and especially in the airline industry. So your components have to be really reliable, which are able to work at different temperature ranges and also able to work reliably over a period of long period of time. So in automotive, we talk about 15 years of product life, and then the components have to survive till 15 years. And this is how the products are validated in an industry where companies are spending huge amount of money in validating this component against their thermal parameters, then against the different environmental factors, where you have rain, where you have some thermal shocks, where your products is going from high temperature range to low temperature ranges, and then you have some different kind of ISO pulses which are ranging beyond the product specifications. So products are really rigorously tested, and that's the reason this industry is very capital intensive industry. And then another big challenge what you see in circuit design, which is not mentioned here, is the EMI EMC. So this is really important, that when you design a product, you need to really understand that under which area my product is going to operate. So if there are and if there is an environment which is surrounded by many switching devices like antennas and so on, and then you will have the interference from this neighboring devices to your device, and there are chances that your product could not work as expected if there are switching devices inside your product. So this is really really important. And as the designs are getting miniaturized, yeah, you are having too much of integrations getting done into a product. So this area is really important, that we care about EMI EMC. And as I said, here also companies spend huge money in getting EMI EMC certification for the product, and it is not that easy. And designer has to have a very good understanding of this area, that the design which is done is also EMI EMC capable, that it is not affecting the other products which are in surrounding with this product. So it really depends in the environment wherein which your product is operating. So these are the few key points which are posing challenges in the circuit design. And today in an industry, there are two important tools. There are, of course, there are many other tools which are used for simulation, but these are the two key tools which are used in every industry, is the LT Spice and P Spice. So LT Spice is from the analog devices, and this is freely available. So even a college student can download it and can use it and gain the understanding that how it works. And P Spice, it is from Cadence, and it's a paid software because it has got many advanced feature which is not needed for for college going student in the beginning, but for industry it is very very important, and that's the reason companies pay for it and buy the license and then use it. So but for a college students, I think the LT spice is sufficient just to gain an understanding how the circuit would behave by giving the required input and then looking at the output, what is expected. So just to give you an idea that how the tool looks like. So I just created a very simple circuit. It's called voltage divider circuit. Now there are three ways in which any hardware circuit you can verify the design. One is by knowing the theory. That means in theory you know how the circuit works and you know the formula, and then you are able to theoretically calculate that how much voltage you will expect at the midpoint between R1 and R2. So I've just shown you that if this is the circuit, then we should expect 2.5 volt at the midpoint of R1 and R2. And the another way of verifying this circuit is to do an simulation. That means you construct this circuit using the simulation tool, and then you apply the required input, and then you see the output, whether the design circuit is meeting the need of it or not. And the third way of verifying is to really going into the lab, then constructing this circuit either on a bare board or a PCB, and then checking and then giving the required input and then checking the output. So we just quickly take a look into the simulation tool, and here you can see the LT Spice, the simulation tool window. So here basically you have got options of different components. So this is a ground component, then you have got a labeling where you can give the label to the nets, then you can select resistors, capacitors, inductors, diodes, then you can select other components if you're looking for. So there is a library so inside this LT Spice, and so you can select LED, you can select MOSFET, you can select NPN transistors, so what you're looking for. So based on the need we can select the components. So you can select TVS diode, varactors, and Schottky diodes. And so since I have taken for the basic understanding a very simple circuit of voltage divider, so then here we have selected two resistor pull up and pull down resistors, and then we are interested in the voltage at the midpoint, and the input to this circuit is 5 volt. Now let's see, if we simulate this circuit, do we really get 2.5 volt? So you can see it that we are getting 2.5 volt. That means in principle this circuit is working and the selection of the component is okay. So just to we need to keep in mind that this is a very basic simulation, but when we talk about the industrialized design, we need to keep in mind the operating range of this resistor before selecting this resistor. So I mean the selection of the component is really important. We cannot just select the resistors just because it matches the value. So we need to really see the operating parameters of the component, be it a resistor, capacitors, and transistors, MOSFET, and then we need to suitably select the component which can meet the needs of our design. So this is really important in a hardware industry. So moving on next. So these are, I think, hardware products. I think most of us know. On the left hand side you see a lot of consumer products like mobile phones, laptops, and then in the middle you see it's an automotive domain, so you see a car, and then there are a lot of hardware products like sensors and actuators which are used in the car, like pressure sensors, temperature sensors, like throttle position sensors, egg pedal sensors. Then you've got throttle motors, then you've got some loads like walls and all that. So you need to design a circuit with which you could drive these different types of sensors and actuators. Then there are a lot of different units which are used in the car, like body control unit, electronic control unit, you have the gateway control unit, you have the transmission control unit. So these are all hardware products. And then on the right hand side what you see is this home appliances industry. So you see refrigerators, you see microwave ovens, and the washing machines, kettles, and so on, iron machine, and so on. So these are, I think, needless to say, I think every product needs the hardware. So without hardware you cannot just have a product, Of course, then on top of that, you have got a software by using which you can enhance the feature of the product, but then the base is hardware. And then here we talk about in brief the different job roles in an industry. So what one could expect once he joins the hardware industry. So as a fresher, you start as an hardware design engineer, and I think it would take generally 3 to 4 years for a person to get an understanding of how hardware industry works, how the products are designed, and to get a brief understanding that how to make a design which is industry relevant. So maybe with an experience of 3 to 4 years, and based on your learning ability, that how fast you are able to grasp and learn the concept, so you get promoted to a senior hardware design engineer, so where you take the responsibility of a project, your own project, and then you are made responsible for the design and development of the product. And with again gaining certain years of experience, you get promoted to a design specialist, where in which you are in a position to not only propose the solution, but also you are able to mentor the people within your team and outside the team. And then after a specialist, you become an architect, wherein which you have a very bigger responsibility of leading the design team, not only in your team but also at the department level. That means around, it's a team of 150 or 200 people, where you're not directly responsible for design, but then you are responsible for proposing the solution and guiding the team towards the development of the different product applications. And then you become coach with certain years of experience. So I think from one step to others, normally it would take 3 to 4 years for an individual to go from one level to another. So it totally depends on your learning and learning abilities, and then how fast you are able to propose the solutions and design and develop the product which are industry standard capable. Then here are the few good companies. So of course, there are many hardware companies, needless to say. So these are just a very few companies which are operating in the hardware domain and could give you the good growth opportunities in the hardware domain, like Bosch, Continental, Honeywell, I think well known in the aerospace industries, also in the sensors and actuator space. Then we have got Cisco, which is mainly in the networking domain, telecommunications. We have got General Electric. Then we have got Samsung. So these are all well-known companies, but of course the list is very huge. There are many companies you could find which are operating in the hardware area.